Properties of division of rational number. Some properties of division of rational number are different from integers. Closure property. If a by b and c by d are any two rational number such that c by d is not equal to 0, then a by b into c divided by c by d is also a rational number. But in case of integers, it is not necessary that the quotient is also an integer. For example, 5 by 9 divided by 15 by 18, which is equal to 5 by 9 into minus 18 by 15. Here, when I reciprocal the number, the divide changes into multiplication, which is equal to minus 2 by 3, which is a rational number. But 2 divided by 3 is equal to 2 by 3, which is not an integer. In integers, there is no need for the quotient to come as an integer as well. It can come as a rational number too. Commutative property and associative properties. Just like integers, divisions of rational numbers is neither commutative nor associative. Thus, if a by b, c by d, and e by f are any three non-zero rational numbers, then a by b divided by c by d is not equal to c by d divided by a by b, except for a by b is equal to c by d, and a by b divided by c by d divided by e by f is not equal to a by b into divided by c by d by e by f. So, the commutative property and associative property is not verified for divisions of integers nor rational numbers. Property of 1 and minus 1. For any rational number, we have a by b divided by 1 is equal to a by b, and a by b divided by minus 1 is equal to minus a by b. So, if a rational number is divided by 1, then the answer will be the rational number itself. If a rational number is divided by minus 1, then the answer will be a negative of the rational number. Division by itself. For any rational number, a by b is not equal to 0. We have a by b divided by a by b is equal to 1. And division of its own additive inverse for any rational number. If a by b is not equal to 0, we have a by b divided by minus a by b is minus 1. Inserting rational number between two given rational number. There is no integer between two consecutive rational number. Let we have two non-consecutive integers like m and n, where n is greater than m. Hence, there are n minus m minus 1 integer in all. For example, between two consecutive integers 2 and 3, there lie infinite numbers of rational numbers. Find 2 plus 3 by 2, which is 5 by 2, is a rational number between 2 and 3. And 2 is lesser than 5 by 2, and 5 by 2 is lesser than 3. Similarly, find 2 plus 5 by 2 by 2, which is equal to 9 by 4, and 5 by 2 plus 3 by 2 is equal to 11 by 4. Both are rational numbers, which gives us 2, next 9 by 4, next 5 by 2, and 11 by 4, and then 3. So there are 3 rational numbers between 2 and 3, and they are infinite rational numbers, and not even these. If we proceed in the above manner, we can find as many rational numbers in the between of two numbers as we desire. In this way, we can insert infinite rational numbers between any two given integers. More so, in the in between any two rational numbers. If x and y are two rational numbers such that x is lesser than y, then x plus y by 2, a rational number, and x is lesser than x plus y by 2 and then y, and so on. Alternate method. For example, to find numbers between 2 by 5 and 9 by 11, follow the following steps. Find the equivalent rational numbers having a common denominator, say 55. Because 5 and 11 has the common denominator as 55, which is 2 by 5 is equal to 2 by 5 into 11 by 11, which is equal to 22 by 25. And 9 by 11, when we multiply it to get a common denominator to the both of the rational numbers, then 9 by 11 into 5 into 5 into 5 by 5, which is equal to 45 by 55. Choose integers between the numerators 45, 22 and 1, which is equal to 22 rational numbers. Form a rational number with these integers as numerators and denominators. That is, form 23 by 55, 24 by 55, 25 by 55, and so on. It goes on. Okay? Well, this is an easy method than the previous one. Insert three rational numbers between 5 and 6.5. A rational number between 5 and 6.5 is equal to 5 plus 6.5 by 2, which is 11.5 by 2. When we divide this, we get 5.75 is a rational number between 6 and 5 and 6.5 at the middle. And if we want to find the rational number between the the middle one and the starting one, a rational number between 5 and 5.75, which is equal to 5 plus 5.75 by 2, which is equal to 10.75 by 2, which gives our answer 5.375. A rational number between 5.75 and 6.5, we get 5.75 plus 6.5 by 2, which is 12.25 by 2, and we get answer as 6.125. Therefore, three rational numbers between 5 and 6.5 and 5.75, 5.375 and 6.125. Okay. Ordering of rational numbers. We can arrange a rational number in ascending or descending order by converting their each rational number into a n equivalent rational number with denominator equal to the LCM of the denominator of given rational number. Arrange minus 3 by 6, minus 3 by 4, 7 by 4 and 3 by 5 in ascending and descending order. LCM of 3, 4, 5 and 6 is equal to 60, which is a least common factor which gives our denominators. You should take LCM only for the denominators. So when we should multiply minus 3 by 6 into 10, and which is equal to 10 by 10, and which is equal to minus 30 by 60. We should multiply 15 by 15 to minus 3 by 4 to get minus 45 by 60. 7 by 4, we should multiply 15 by 15 to get 105 by 60, which 4 by 3, we should multiply 20 by 20 to get 80 by 60, and 3 by 5, we should multiply 12 by 12 to get 36 by 60, which gives our ascending order as minus 45 by 60 is lesser than minus 30 by 60, and then 36 by 60, 80 by 60, and 105 by 60. This is an ascending order. Okay, if I put it like this, I want it to be in a real number, so I just substitute it in the number given. So minus 3 by 4, minus 3 by 6, 3 by 5, 4 by 3, 7 by 4. In descending order, 7 by 4, 4 by 3, 3 by 5, minus 3 by 6, and minus 3 by 4.